Hello everyone, it is Mr. Shark Spambot here, and in today's video I'm going to be talking about the Cadaverous Cipher, which is a simple encryption algorithm which I've made. Let me go back to the first version and I will explain how I've changed it over time. Oh, and by the way, I am currently trying to learn cryptography. I found it very interesting. So, this original one, this is a monoalphabetic substitution cipher. And a substitution cipher, the way it works is basically that each character has a unique substitute, and at least in a monoalphabetic one, and it is replaced with that substitute. So the substitutes are chosen randomly from a character between 0 and a million. This is with mapping with the CHR. This makes sure to check that no characters are the same, and if it's not the same, it is updated to this dictionary. Now what this basically does is it replaces every character with its substitute, and this code here, it undoes that in a decrypt function. Now looking at version 1.1, this is now polyalphabetic, so it generates exactly 2 dictionaries. It is about the same thing, and the way this one works is that there are 2 characters, the first and the second, and it iterates over that. So you'll look at ciphertext such as this right here. This is the power of the Cadaverous Cipher. Now the first character, T, gets encrypted with the first dictionary, the H gets encrypted with the second dictionary, the I gets encrypted with the first, and this is the second, and so on. This is stronger, however, it is still vulnerable to frequency analysis. And that is why I created a permutation-based version. Now this is more complex, and what basically it does is, first of all, there are multiple dictionaries, how many you want to choose really, and if you look down, what this does is it iterates over the sliced text, and this text is split up based off of how many dictionaries there are, and it encrypts based off of each permutation. So essentially, let me show a diagram here by just so what I could do is look at permutations and say that I just want between a range of 1 and 6. Now, the way this encryption algorithm works is it encrypts in this order. So it uses, for example, if you have 5 dictionaries, it uses dictionary 1 for the first character, the dictionary 2, then dictionary 3, then dictionary 4, then dictionary 5 for the first 5 set of characters. The next 5 set of characters, it goes dictionary 1, dictionary 2, dictionary 3, dictionary 5, and dictionary 4, and so on. And the more and more dictionaries you have makes the encryption more and more secure. However, if you have too many dictionaries, then the file size for the key, the dictionary key, would be too large. And this is a problem with a substitution cipher itself, is that the more characters, the more substitutes you want, the longer the key has to be, making it not really accessible and not really plausible to use on a larger scale. But this was just a basic for fun substitution cipher, just to learn encryption, and yeah, I had fun with making this, so I thought I'd make a video on this. and this reverses what is being done, and this loop here, this slices the text into every, that amount of text. It's between, I don't know, 0, then the length of the text, then the length of the dictionary. So this is executed every time, every length of the dictionary keys. So like, say every 5 times. So it'll be like 0, then 5, then 10, then 15, and that's the order which it executes in. So it can slice the text. And another thing is what really helpful for encryption, and especially when you're using iterations, is the itertools.zip longest, because ciphertext, it can be an odd number, like the length of it can be an odd number. In that case, zip will not work because there'll be that last character which will not be able to decrypt. So what zip longest does is it appends none, the none value, and you could just check if there is a none value and then break it. This is also helpful when you're implementing a railfence cipher and you're trying to decrypt a double railfence cipher. This function is very helpful. So yeah, pretty short video, but I just wanted to go over this. And yeah, I really haven't been posting in a while. I've been really busy with school. I mean, school's out now. I've been learning cryptography, assembly, and reverse engineering, and I do hope to make videos on all of these things as I learn more and more. But thank you for watching this video. If you like this video, please hit that like button and subscribe to the channel.